Hey everybody, welcome to class. I just started our live stream and let's maybe wait just 1 or 2 more minutes and we'll get started. Okay, let's go ahead and get started. Sorry for all the back and forth. I'm just getting set up in my office for the first time, and I have a new monitor, and everything seems to be working just a little bit differently today. But I think we got it sorted. So today we're going to be doing something of a little bit of a different flavor, and we're going to be talking about the ethics of data science. So this, will be a little bit of a different flavor, but a very important topic related to this course. Okay, and I wanted to let you know that today's lecture materials are actually taken from an external resource that I found. It's a free online course put together by a professor at the University of Michigan in data science ethics, and it's a really great resource. They talk about a lot of different topics, and it's free, so you can enroll in that. If you want to get access to all of the materials, I'm going to kind of give an overview and talk about a few of the topics today, but there's a lot more that we won't have time to discuss. So I encourage you to do that if you're interested. This is the the course is by Dr. H.B. Jagadish, and it has a lot of good stuff. Okay, so what we are going to be doing today is talking about a few different topics. First of all, we'll start with the basics, which is what are ethics. Then we'll talk a little bit about informed consent, data ownership, algorithmic fairness, and then finally societal consequences. Okay, so first of all, when we're talking about the ethics of data science, well, what are ethics? How do we define that even in the first place? Well, ethics are generally shared principles that help us distinguish right from wrong, and really a cornerstone of civilization. Without people sort of agreeing upon some notion of ethics, it would be very difficult for civilization to function. And so they're the basis for the rules that we all voluntarily choose to follow in order to make the world a better place for all of us. Okay, and so ethics is exactly what prevents me from stealing your wallet. Say, even if you are smaller and weaker than I am, and even if there is no chance that I will be caught, there's still something that's preventing me from doing that. I mean, of course, not all of the time, but in general as a society. It's important to distinguish ethics from religion. So ethics are not religion, although there can be some relationships here. Most religions promote ethical behavior, such as, the famous commandment, thou shalt not steal. But ethics need not be religious. Ethics flow from a sense of shared values, which could be on account of religion or could not. Okay, so there can be some, I guess, correlation, but it's not religion. Another thing that ethics are not is ethics are not laws. So there are a lot of things that we might do that would kind of generally be agreed upon to be unethical, but that are perfectly legal to do. For example, if you tell your friend a secret and they promise not to tell anyone, and then they go around and for no good reason, tell everybody your secret and spread a lot of gossip, we would all agree, well, that's unethical, but it's not against the law, usually. Okay, so even though ethics are not laws, ethics do guide the creation of laws. So the two are often in consonance with each other. And of course, not everyone will be ethical, even when there are shared values. And that's why, of course, we have certain people go to jail for theft. But the laws may be used to enforce ethical behavior. Okay. And for the most part, we are sort of all better off as a society because of ethics. So as a whole, society as a whole does best when each individual works to maximize their own individual benefit. But there are situations where what benefits you individually as a person contradicts or is in opposition to what is most beneficial for society. And sort of our shared societal value systems help us sort of navigate those types of situations. So a famous example of this is known as the tragedy of the commons. And the idea here is that, let's say I have my own private land and I graze my sheep on my land, but then there's this really nice common area, green and grassy, and I would like to graze my sheep there too. So I could do that and it would benefit me. But of course, the problem is that if everybody does that, what happens to the commons? Well, they are no more. They get overgrazed and the grass dies, and then it's not nice for anybody to enjoy. Okay, so this is a good example to kind of keep in mind when we're thinking about, what are ethics. So basically, the rules that we kind of agree upon in society are those where the cost to me of following that rule is less than the benefit to me from others following the rule. So it's something that we can all agree to, because we're all better off if everybody follows those rules. And so that should make everybody want the rule, even if there is a cost to the individual in certain situations. Okay. And of course, you could think about this, another example would be driving on the right side of the road. This may be inconvenient at times. You might be able to drive faster if you could drive anywhere you want. However, if we don't have this rule, if we don't all drive on the right side of the road, there's chaos. And if everybody's driving wherever they want, the cost to me will be much larger than the cost of me just driving on the right side of the road. Okay, and another example, would be litter. We'll skip over sort of that. Okay, so in summary, kind of related to what are ethics, ethics are shared rules we all agree to follow because of the resulting benefits. And so they are often infused with a sense of right and wrong. But generally, these rules are driven by the fact that we're all better off with ethical behavior. Okay, so that just kind of gives us a little bit of foundation about, what are ethics? What do we mean by that? And now let's move on and talk a little bit about informed consent. So, so this is a very important topic in data science. So ethics is really important in data science because it affects humans. It has an impact on humans. And so to really understand that, there has to be a discussion about human subjects research and informed consent. And this is a concept that has been more developed recently. And one really famous example where there was that kind of spurred a lot of discussion on this is the Tuskegee study that took place from 1932 to 1972 in Macon County, Alabama. And in this study, there were 600 impoverished Black sharecroppers who were enrolled in the study. And the goal of the study was to study the effects of untreated syphilis. And in the group, there were about 400 people with syphilis and about 200 people without. And they gave the participants free health care and hot meals, and they just sort of followed them over a period of time to study the effects of untreated syphilis. So this may sound, fine, good to advance medical knowledge, but the problem that happened was that penicillin became the standard treatment for syphilis in 1947. So it became standard practice to give this as a treatment. But the subjects in the study were never informed about that, and they were never given that option. So this led to a public outcry in 1972 and led to the formation of IRBs, or institutional review boards. And institutional review boards, they basically govern the concept of informed consent, which is necessary for human subject research. And so what it means for research with human subjects is that the human subject must be informed about the experiment, they must consent to the experiment voluntarily without coercion, and they must have the right to withdraw their consent at any time. And so if we sort of think about the Tuskegee study, we can see how it doesn't quite line up with this standard. Were the participants informed about the experiment? No, they didn't, they were not really informed on the nature of the experiment and consequences of participation. They did consent to the experiment voluntarily, so that part was true. Did they have the right to withdraw consent at any time? That's a little unclear, so probably not quite. No one ever told them that they could leave the study. So maybe it's a little unclear. But kind of the problem in that situation is that the benefit versus harm was assessed by the experimenter. So the researchers conducting the study thought overall we'd be better off by advancing medical knowledge about syphilis. And so they decided it would be better just to keep the experiment going without interfering by offering the people treatment. But of course, if the participants had been the one to make the, to sort of weigh that decision about does the cost to me outweigh the benefit to society, they probably would have come to a different conclusion. And so that has become the role of institutional review boards, is to make that call. What's the right balance so that the experimenter is not doing that? And these usually consist of a group of diverse members, not all scientists, and they approve human subject studies before they occur. And they also manage necessary violations if there are violations of informed consent. Sometimes this is necessary. For example, there are certain experiments in psychology that just could not be done if the participants were told all of the details of the experiment. So a lot of times, there's something that they want to study regarding, how your psychology works when you're told something that's not true, or they don't want to tell you the intent of the study, or it'll ruin the results. But in those cases, so there are some exceptions to this policy of informed consent, but the exceptions have to be approved and cause as minimal distress to the participants as possible. Okay, so here, when we're talking about human subjects research, there's this idea of prospective data collection, so that the whole process is analyzed before the data is actually collected. An IRB review is required, and this is driven by, sort of the excesses in the past of medical research. And this is enforced by US federal law only for government-funded experiments. And so it, for example, applies to user studies in computer science. However, so if you were, an academic doing research at a university in computer science, you would have to follow these policies. And if you were doing research involving human subjects, it would have to meet all of these criteria. But it's important to understand that there's a different bar when it comes to business and research. So this is not required if you're a business and not research. There's no institutional review board that's reviewing things or making sure that you're not causing harm. Okay, and we talked about, this is one topic we talked about previously in this course, the notion of A/B testing, which has become really widespread and really prominent, where companies, will show one set of their users a certain web page and another set of users different web page, and then they track their behavior and they see, well, which group bought more, and then they will sort of use these experiments to tweak the design of their web pages, etc. And this would be considered fine. This is a business that would not be sort of subject to sort of the bar of informed consent, even though these changes are impacting users and they're not being informed about it. Okay, so would this be considered human subjects research? Yeah, really no. So companies do this all of the time, and human users are impacted, and the companies do try to push our buttons to buy more. So they are trying to impact our behavior. And they can have bad algorithms that make bad predictions and give poor results, and there can be a negative impact on the humans involved. But in general, this is considered okay. But it starts to get a little murky as we go a little further into this. So there was a famous experiment done by Facebook and Cornell, where so what happened in the experiment was they put negative news articles in the Facebook feeds of a certain group of people, and then they put positive article feeds in the feeds of other people, and then they sort of tracked what those people posted, and they found a correlation there. So the users who were subjective to these negative news articles posted more negative items themselves, and the users who were subjected to the more positive news articles posted more positive items. And so they were studying this sort of artifact of emotional contagion, right? That our emotions are impacted by what we're exposed to, and this affects our behavior, which is, of course, that's very interesting. It's an interesting thing to know. But there was a big outcry when this came out that they had done this, and people were very upset that Facebook had sort of manipulated their streams without telling them. They felt lied to about this. Okay. So now their user agreement permits Facebook to use data for research explicitly after 2012. Okay, so yeah, so it's really interesting. I feel like there's kind of a whole spectrum of things. We look at A/B testing, and most of us would say, oh, that's fine. That's not hurting anybody. And then we look at something that happened with like the Facebook study with Cornell, and that's like, yeah, that's a little gray. People got upset. Some people felt that really wasn't appropriate. But there's not a whole lot, we're sort of growing as a society and having these conversations and trying to develop a consensus around what is right and what is wrong in these instances. And so there's becoming a consensus that companies should not lie to us intentionally, even if the effects are pretty similar to their normal operating procedure. And another example where this occurred was with the company OkCupid. And actually, so this is kind of an interesting story. So I'm going to watch a little video on this case study. Let's see here.
Matchmaking companies exist on the web. OkCupid is one of them. The way these things work is customers sign up, enter a profile, and the company tries to find compatibility between user profiles based on what you've told about yourself. You'll be recommended people to meet that the company thinks might be compatible with you. Determining compatibility is, of course, extremely difficult, and a company like OkCupid has a proprietary algorithm to try to predict this compatibility. They do so by means of developing a compatibility score that is computed through some proprietary function of all the different things that you have in your profile. Of course, they're trying all the time to improve their algorithm and improve the predictive power of the compatibility score that they create. And for this purpose, they're constantly monitoring how well they do. They're constantly tinkering with the algorithm, trying to improve it, change some weights, change parameters. And some of these changes may be successful and may be adopted, others may be rolled back. And so in this sense, if you're a user of a website like OkCupid, you're constantly being experimented upon, in that what you're experiencing is an algorithm that is perpetually in development. Now, OkCupid actually took this thing a couple of steps further. They tried slightly bigger experiments. So, for example, the thing that they started to do was something called the Love is Blind Day. And on this day, they would suppress photographs in user profiles. And what this meant was that you would not be able to see the profile photographs of potential people to meet. You would, of course, be able to read what they had written in their profile in terms of their interests and other text attributes. What they found was that even though as humans, we all very much care about photographs, and that is likely to be a large part of the input in terms of our deciding if somebody looks interesting and attractive, that not having those profile pictures actually resulted in more conversations, more dates, and in that sense, their platform was actually more successful on this day, on the Love is Blind Day. So taking this kind of counterintuitive success another step further, OkCupid decided to try an experiment where they wanted to understand the impact on the success of a date of simply being told that you were compatible. And so what they did was took people who were actually not very compatible, had a low compatibility score, and falsely told them that they had a high compatibility score just to bring people together. Conversely, they also took people who had a high compatibility score and told them they had a low compatibility score. And they actually did a 3x3 matrix of this sort with 30, 60, and 90% compatibility score, actual versus 30, 60, 90% declared. And what they found was the success rate was the highest when people were compatible and were told they were compatible, that is at the 90-90 entry of this matrix. And it was lowest where they were not compatible and were told they were not compatible at the 30-30 entry of this matrix. That if people were not compatible, but were told they were compatible, they actually did pretty well. And in fact, they did just as well as if they were compatible, but were told they were not. This is an interesting insight into human behavior. And this experiment was reported by the CEO of OkCupid in a blog post. When he reported this, he was cured on the internet by a whole range of people. And fundamentally, what this says is, in doing this experiment, interesting as it might be, that OkCupid broke the unwritten expectations of society. The CEO, Christian Rudder, obviously didn't agree with this general social consensus, or maybe there wasn't enough of a social consensus that he and other people like him would think it perfectly acceptable to do what they did in terms of reporting compatibility scores that were intentionally incorrect. Really, what we're doing here is, I think, socially drawing a line between experiments that companies conduct in the normal course of business because they're trying to improve their product or improve their algorithm. And yes, sometimes hope for improvements may turn out not to be improvements. Sometimes companies actually tell you something completely wrong, but that's unintentional. And that kind of thing we accept as just the way the world is. On the other hand, having a company intentionally lie to you, intentionally give you a wrong score, is something that most people would consider socially unacceptable. And because of this particular experiment and the discussions that followed, I would say that this is a matter on which there is greater social consensus today than there was at the time that OkCupid actually did conduct this experiment.
Okay, so yeah, that's, I found that a very interesting case study and an interesting illustration of, some of these principles. Um, and indeed, as we have had more and more data become available and technology be bigger and bigger parts of our lives, it's taken some time for us to come to a consensus as a society about what's right and what's wrong, what's acceptable and what's not. And I think there's still room for growth there and room for further consensus, but we've made some progress, and now there's bigger consensus around the responsibility of businesses in those situations. Anybody have any comments or thoughts on the OkCupid situation?
Yeah, it's kind of interesting seeing how companies like approach this kind of subject, because they're looking at it from a totally different perspective than like research. They're looking at pure like profit and like its direct impact on business versus like just trying to see what behavior is and stuff.
Yeah. And I'm not quite sure what their motivation was. I mean, like, it's interesting, but it almost seemed like more like research, that you would do into human psychology. I'm not quite sure, how it benefited them in improving their.
I mean, I guess with like maybe for them, like trying to improve their algorithm to see, the compatibility scores, see if they can improve like how like frequent or accurate those were, I guess, and really see what those values actually mean through the experiment.
Yeah. It's really interesting to think about, and surprising to me that like, what, they could do that? They didn't go to jail for that, but apparently not.
The only thing I find a little interesting is that companies tend to get in trouble once they share results on these things.
Yeah.
And it does make me wonder how much of this is just happening constantly behind the scenes without, anyone knowing about it.
Yeah, that's right. That's a great observation, because they didn't have to make that public. Yeah, they could have just kept that to themselves, and I think they made it public because they didn't see a problem with it. I don't think that they foresaw that there was something people were going to be super upset about. But yeah, I imagine that there is a lot, and to a certain extent, some of that's reasonable. I mean, it may be, there's some things, there's like some data that companies collect that it's good they don't make public, but this sort of crosses the line of lying to people. Okay, great, thanks for everybody's insights. Okay, so we already did that. Okay, so let's talk a little bit about data ownership, which we kind of started to briefly there at the end. And this is also kind of a tricky topic. You can think, for example, if somebody writes a book about you, somebody writes a biography, it's about you, but you don't own the book. It's not really yours. If I write that book, I own the copyright. And if you don't like what I say, there's really not a whole lot you can do about it, except for sue me if I actually, state inaccurate things. But if you just don't like it, there's really not a whole lot you can do. And sort of a similar principle holds with photography also. So if I take a picture of you, even though it's a picture of you, I still own that photograph. And there are limits on what I can do with it. So there may be some limits on taking the photo in certain private areas, like you can't take a picture of someone in their home or bathroom, or on using the photo in certain ways. You can't take somebody's picture and then use it as an implied endorsement. But so there are certain limits on what you can do with that picture. At the same time, you still own that picture. I don't own that picture. And then this can also lead to a lot of times people creating unflattering photos, such as this one where they started with a picture of somebody and then they tweaked it to make it insulting and unflattering. Yeah, and of course we all have days maybe where we're not when we're not at our best, and we don't want somebody taking a picture of us and making it public. Okay, but really with cameras everywhere today, these unflattering moments are really easy to capture, and they do get captured a lot. So it's not hard to do, to find an unflattering picture of somebody and to take advantage of it. And this can be implied libel. Okay, so that's just kind of like a little bit of background to think about books and pictures, who owns them, even though they are about somebody. A similar principle applies to data ownership, actually. There's similar limits on what data I can record about you and what I can do with it after. But otherwise, I'm free to record that data and I'm free to use it subject to those limits. So this is, maybe a little bit surprising, or maybe a little bit counterintuitive. You might think that, well, if data is about me, I should have some rights to it, or I should have some ownership in that. But unfortunately, you really don't have a whole lot of ownership in that data. The person who records the data, collects the data, kind of has the data ownership. Okay, and so just a little kind of recap here of some basics on intellectual property. There's three kinds of intellectual property. There's copyright, which governs regulations around artistic expression, right? Like images and books, etc. There are patents, which is governs regulations around somebody's idea for making or doing something, and then also trade secrets. I have it, but don't tell anyone. And so in terms of how we use the data, if I use an image, I display it and I can credit the owner. In a similar way, if I use your data, I am almost always taking some piece of what you know, merging it with what I know, and then expressing something new. So this is where it's actually a little bit harder with data, maybe than just like with images. With an image, you can use it, you can credit the source. But what happens a lot with data is this merging from multiple sources. I get some data from you and some data from here and some data from there. And I put it all together and I do my analysis. And exactly who you need to credit and how can be a little bit more complex.
And we're getting just a little bit of crackling on your mic at the moment. I don't know if it's rubbing up against something.
I don't know if it's rubbing against anything. Is that any better?
Could you say some more words?
Is that any better? Is it bad?
It sounds similar. I don't know. It might be the internet connection. I don't know.
Like I said, I'm in a new setup today, and I am a little bit untested in terms of the internet connection. Are other people having issue? Okay, also hear the crackling. Okay, all right, I am sorry about that. Unfortunately, I probably can't fix it now because I'm gonna have to address the connectivity here. But hopefully you can understand it and hopefully we can go through the class. Okay. Okay, so let me see what time we're looking at. Okay, I'm gonna maybe skip through some of this. Yeah, I'm gonna skip this. Okay, let's do right. Okay, so so we've sort of talked about this concept that even though the data is about me, I don't really own the data. The person who records it owns the data. But there are, and this necessitates that there are limits related to that recording of data. So recording is wrong when there is reasonable expectation of privacy. For example, no cameras in a clothing store fitting room, etc. And similarly, you know, the phone company must not record the content of phone calls. There's also an expectation of that privacy. Of course, we could agree otherwise under certain circumstances. You know, you could pose for a photographer and agree that they will give you ownership of the photo, or you could agree to participate in a research experiment that has informed consent, or a funding agency could require that the data collected be made public, right? So there are exceptions to that. Okay, and let me go ahead and so sort of so much to discuss related to this. I think I kind of overestimated what we could get through in one class, but I think instead of going through all these slides, I'd like to look at the case studies because those are kind of interesting. Okay, so in terms of limits on use, there's often a strong reason to record the data, but also potential for misuse. I mean, so security cameras are a good example of that. So there is a strong reason to record that data, but of course it could be misused against people if it's not properly managed. But it's generally preferable to limit the use rather than the recording. Like it's okay that they take that footage from the security camera, but they can't do whatever they want with it. And this allows desired legitimate use while disallowing other undesirable use. Okay, so yeah, let's go to the case study here. Okay, so this one's on, so that this is an interesting one to think about in terms of data ownership, and it's about the website ratemyprofessor.com.
Students care about how well professors teach. And when enrolling for a class, they would naturally like to find out a little bit about how good the professor is. To meet this need, there are several websites that have cropped up. For example, ratemyprofessors.com. On this website, students who have taken my class go in and enter their comments and their rating of me as a professor. Other students who are considering taking my class can go read these comments, look at these ratings, and then decide if I'm a good professor or if they should wait till the course is taught by somebody else or not take the class at all. In other words, what happens on this website and the data that's on this website has an impact on enrollments in my class and therefore potentially on my career as a professor. The thing is, this is intensely personal information about me, but it is about me said by somebody else and recorded on a third-party website that I have no control over, and in fact, in general, have very little interaction with. Now, the question is, what happens if there's data, the things that are said on this website that I object to. For example, suppose there is some student who is disgruntled. Let's say I caught some student cheating. They could go in and put a really nasty comment about me and rate me very low. Even worse, there isn't much that prevents them from getting 50 of their closest friends, let's say their frat buddies, to go in and do the same thing. And the net result of this kind of mass movement would be that my ratings on this site would plummet. If such a thing were to happen, I could presumably go and complain to the website, and possibly they would investigate, possibly they might do something. But it's really totally up to them and their processes, and I have no real recourse. But the data has been gathered by somebody else, and it is this somebody else who controls it. The data that a site like ratemyprofessors.com gathers is information that they could sell or rent to third parties, that they could do what they wish to with. It is about me, but it isn't mine. And keeping this distinction between who the data is about and who owns that data is important as we go through our discussions of privacy.
Okay, so yeah, I also found that to be a really interesting example. Yeah, any comments or thoughts on that case study, on this this aspect of the data that's generated, who owns it, and the potential misuse that can occur?
I would say that's pretty insignificant to the amount of data that credit bureaus collect about you.
That it's yeah, but we do see and this, I think it's a good example though of where in the majority of cases it's kind of a good thing when it functions as intended, but there is a potential for abuse. And when that happens, there's not a whole lot of recourse. So that's kind of a good thing to keep in mind, I think, is we're data science practitioners, and maybe we're people who contribute to the construction of these kind of tools, like these websites and these data collection mechanisms. Can we think through it ahead of time? Can we try to think about the ethical implications and try to think about how people could be impacted and what mechanisms we could set in place to try to prevent some of those abuses? Okay, why don't we, so we're a little, I know we were supposed to take our break a while ago, but I sort of thought we would get to the end of this. Why don't we go ahead and take our 5-minute break? And so it's 1:13 now. Let's come back at 1:18, and then we'll talk a little bit about algorithmic fairness, and which I think will be a lot of interesting topics there. So I'll see you back in a few minutes. Okay, hey everybody, welcome back. And I tried plugging in my internet. Is the sound any better? Is that, well, let me keep talking so that you can assess it. Does that sound better than before? Okay, awesome, great, thank you. Okay, so hopefully that will be less frustrating for the remainder of the class. Okay, so now we're going to move on to a really important topic in the ethics of data science, which is algorithmic fairness. So a lot of times, you know, there's this way of thinking that, well, the data speaks for itself. You know, a data analysis, if it's done right, then there's no problem. But we're going to think about ways in which maybe that's not true. Do the data really speak for themselves? Can algorithms be biased? And can we make algorithms unbiased? So some good questions to think about are, is the training data set representative of the population? If you start off with a data set that's not representative of the population, then you may get biased results, especially in terms of the people that were not appropriately represented or adequately represented. Is the past population representative of the future population, and are observed correlations due to confounding processes? Okay, and what can occur here is an algorithmic vicious cycle. So think about the following example, where a company only has 10% female employees, and this company has a good old boys culture that makes it really hard for women to succeed. Now let's say this company works on a hiring algorithm to try to, you know, help evaluate candidates and predict their success. And they use their past data or their current data in order to construct this algorithm. So based on the current employee success, the algorithm will score the women candidates lower because it's harder for them to succeed in this culture. And then the company ends up hiring even fewer women, and that sort of accentuates this good old boys culture that makes it harder for women to succeed. And it just kind of feeds itself in a vicious cycle, right? So there was sort of, you know, maybe some discrimination there that caused the current data to be what it is, but then the algorithm kind of just keeps perpetuating that because, you know, based on the current data, women are not being as successful. And so they use that in their future hiring decisions, and then the situation gets worse. So it's very complicated, actually, even if they did their data analysis correctly. Okay, and these notions, you'll even see them on TV. I think there was an episode of The Good Wife where they showed how deriving conclusions from poorly sampled data can lead to undesirable results. So you do see this happening a lot. Okay, so this is kind of a good example to keep in mind as we start our discussion. And we want to kind of think about, you know, can we do a bad analysis from good data? Maybe there's nothing wrong with the data, but maybe something is still going wrong in the process. And we'll talk about three things related to this, which is correlated attributes, correct but misleading results, and p-hacking, which we talked about briefly, well, I don't know, a while ago now, towards the beginning of class. Okay, but let's start with correlated attributes. Okay, so for example, consider racial discrimination. Well, universities are prohibited by law from considering race in admissions. They're not allowed to do that. However, it's really not hard to find surrogate features that get them close without violating the letter of the law. For example, this happened in Texas. I believe it was the University of Texas that in their admissions decided they would admit the top 10% from any high school class. And the effect of that, since some of the high schools were primarily African American, was to sort of ensure that that those students got in, that they were accepted, and so that in a way they were sort of able to, have these affirmative action policies without actually using race as the discriminating factor. And similarly, lenders are prohibited by law from redlining or not borrowing to someone on account of race. That is illegal. However, it's really easy to find surrogate features which are highly correlated with race that get them close. They can say, well, we're not going to do that zip code or that neighborhood. They can redline certain neighborhoods without actually specifically saying it's on account of race. So in general, proxy attributes are easy to find, especially in this day of big data where we have so much data. It's easy to find proxy attributes that can be used for discrimination if that's the intent. So as we've seen, big data provides the technology to facilitate such proxy discrimination, and whether this happens becomes a matter of the intent of the person using that data. But on a slightly more positive note, big data also provides the technology to address some of these discrimination issues. Okay, a lot of times discrimination can be unintentional. So hopefully there's another case study I want to look at, which is about what Staples did. And they kind of got in trouble. But they weren't actually intending to discriminate against the poor, but they put in place a policy which ended up, doing that, even when they had no idea that was going to be the effect. Okay, so intent matters, but must be expressed in terms of non-discrimination results. Intent matters, but it's also not enough to guarantee the discrimination won't occur. Okay, but I guess to take a step back, what is discrimination? We've been throwing that word around, but what does it mean? Well, when one target group versus everyone else, if one target group is treated differently than everyone else. And so we can think about this either on the individual level, that we have an individual from a target group treated differently, or we can think about it more on an aggregate level in terms of what happens in society. We can look at sort of the aggregate outcome for a whole group of people, for some kind of minority. Okay. And so yes, unintentional discrimination happens a lot, and it's closely related to data and how we use data. So there were experiments done by Carnegie Mellon in 2015 that showed that significantly fewer women were shown ads for high-paying jobs, for jobs where they would earn over $200,000 than men were. And so clearly that seems like discrimination. Men are getting ads for high-paying jobs and women are not getting ads for high-paying jobs. But I guess the intent of the algorithm was not to discriminate. It was taking the data, doing some kind of appropriate analysis and coming to these conclusions about, what's the most relevant ad for this person, but the effect was still discrimination. Okay, So a second aspect to algorithmic unfairness can be results or analysis that's correct, but misleading. Okay, you've probably all seen pictures like this, maybe if you've had a class in statistics, or maybe you haven't, but the idea is that how you present data can be misleading, even if it's the same data. So in this case, let's say we're looking at the growth of a company over 5 years. And over the course of this 5-year period, we see, okay, sales increased from 100 to 105. The plot on the left makes it look like that's a really drastic growth, that this company is just taking off. The plot on the right, when it's actually plotted on a scale of 0 to 100, shows that, well, no, it's like a very small amount of growth, a little bit, but not a lot. And so how we present the data can be misleading and unfair. Okay, another way that this can happen is kind of by oversimplifying things. Data is complicated, and we kind of reduce it to certain summary statistics like the mean, maybe the standard deviation, but sometimes that really sweeps a lot under the rug that could be very relevant for decision making. For example, let's say we're trying to decide on what hotel to stay at. Hotel A has an average of 3.2 with a mix of mostly 3s and 4s. And Hotel B has an average of 3.2 with a mix of mostly 1s and 5s. So which hotel would you prefer? Even though they have the same average rating, they're very different, right? That distribution of scores, actually tells you a lot of information. Probably with Hotel B, you're either going to love it or you're going to hate it, but there's the potential that you might really love it. And with Hotel A, it's probably just going to be average. But a lot of times, companies will only show the average, right? We don't get all of that data that actually is relevant for the decision. So yeah, there's some more on this, but I think I'm gonna skip over that in the interest of time. Okay, and then another example is sort of the example of being right-handed versus left-handed. And so the right-handed people are definitely in the majority, right? In the vast majority. And designers of products often will choose to cater to that. So a lot of times they will support right-handed people, and they maybe to the detriment of left-handed people, they'll make their products designed for their benefit. And so this is a form of diversity suppression. Okay, so what tends to happen a lot when we think about how data, feeds into algorithms, which then feeds into policy, is that the minority loses. In many, many situations, the minority loses. And this is kind of a good graphic to illustrate why. So let's say we have a population of green and a population of red, and we have two categories, which are good and bad. And we're trying to come up with a classifier, right, to distinguish the good from the bad. So what you can see, so here the red is the majority. I know it's not like a big majority, but it is the majority. The way this classifier is working, because most of the data is red, maybe imagine a situation where there's even more red data. The classifier is distinguishing the good from the bad for the red group, right? But the pattern is actually opposite for the green group. So the classifier it ends up finding does very poorly on the minority. And this is important, right? So we can think about think about how this might affect the minority. For example, if you think about hiring, So let's say that we're going to use data science to find promising prospects. Who should we hire? And our algorithm, the criteria that we use in our algorithm are tuned to fit the majority because that's what most of our data consists of. So that's very normal, that happens. But the effect of that is that the algorithm doesn't work very well then on the minorities. So its predictive power on the minority groups is lower. And this basically has, so two bad things happen as a result of this. So first of all, the best minority applicants may not be hired because the algorithm is not doing a good job predicting which ones are going to be really successful. So this is unfair, right? Because they're not being hired. And then on the other hand, the minority who are hired may not be the best candidates. And so they may not perform as well because they weren't the best candidates to begin with. And so this will again kind of feed into that vicious cycle and unfairly unfairly then sort of the performance of that whole group becomes an unfair representation. And you can also think about how this might play out in medical studies. So for example, let's say you're doing a clinical trial of a new drug to treat diabetes or some other disease. And let's say we have two groups of patients. We have group A and group B. And let's say the drug is very effective for group A and the drug is worthless for group B. Now let's think about, okay, so we've got two groups, one where the drug works really well and another where it does not work well. What's going to happen in this clinical trial if those groups are really unbalanced? So let's say that group A is in the majority. So they comprise the vast majority of people in the study. Well, the drug is going to be found effective because they're the majority and it's working for the majority. And so patients in group B will be given this drug, even though it doesn't work for them. On the other case, if group B is the majority group and the drug does not work for group B, then the drug is found to be ineffective or it's not found to be effective. And it's not going to be given to anybody. It's not going to be approved, even though it would have been really helpful for the minority group, even though it may have worked very well for them. So again, there's sort of these two different ways where the minority group can lose. Okay, let's see. Okay, because we don't have a whole lot of time, let me kind of go through this quickly. I will just say another thing to be aware of is p-hacking. And we talked about this before where, this is especially relevant for really high dimensional data. You may have data that has thousands and thousands of features. And if you run hypothesis tests on each individual one, just by chance, you're going to get a lot of significant effects. But that they may really not be meaningful at all. And so this also relates to when we're thinking about algorithmic fairness, are the procedures that we're using really being used in the way that they were intended, or what are some of the unintended consequences that can happen there? Okay, so I'll skip over kind of some of the details here. Okay, so let's go ahead and kind of summarize the algorithmic fairness here. So humans have many biases and no human is perfectly fair, even with the best of intentions. And so we can have, well, I guess I should say discrimination could be intentional or it could be unintentional. We have biases in algorithms, which are usually easier to measure than in a human, even if the outcome is no fairer. And one thing to kind of keep in mind is that mathematical definitions of fairness can be leveraged to improve fairness. One way in which that could be done is to kind of think about the difference between the effect of a type 1 error and the effect of a type 2 error, and to try to change the weighting of those factors in your algorithm. So there are some things that can be done to sort of address these issues of unfairness, but we have to think through them ahead of time. Okay, so let me do that last case study, because I think that one is really interesting. Because this is one on unintentional discrimination.
Variables are often correlated, and one should not be surprised if one finds that while one thinks that one is dealing with one variable of interest, one is also indirectly dealing with some other variable that one didn't even realize one was dealing with. As an example, consider Staples, the office supply store. As a competitive thing, simply to win business from their competitors, they decided that they would offer a lower price online to customers who lived near one of their competing competitors' stores.
So you're telling me Staples can get me everything on this list at the lowest prices?
Yep, Staples is a 110% price match guarantee for back to school.
So you're telling me the truth?
I 110% guarantee you I'm telling the truth.
So if, for example, if you live within a few miles of an Office Max, you would get a lower price online at Staples than if you were to live not near an Office Max. This seems like a perfectly fine, aggressive, competitive move, and something that we would applaud as good business, potentially. However, further analysis turned out to show that Office Max stores happen to be located in higher income areas, like suburban neighborhoods with bigger houses. And there were no Office Max stores in rural areas or poor neighborhoods. So another way of looking at Staples price discrimination is to say that if you lived in a well-off neighborhood, a good zip code, you would pay a lower price. But if you lived in a poorer neighborhood, you would pay a higher price at Staples. This was not the intention at all of the Staples executives when they launched this campaign, but this was a consequence that flowed directly from the correlation between the locations of their competitors' stores and the mechanism that they were using to vary their prices online. Of course, once this became an issue, they stopped this particular price discrimination campaign. The point is not so much what Staples did, but how does one think through all the different variables that you could be manipulating without knowing that you were.
Okay, yeah, so I think that example is a really interesting one, right? Where they're sort of, they just offer this promotion to try to be competitive with Office Max, and they end up discriminating against the poor. So one question to kind of throw out there is, could it have been prevented? How could it have been prevented? What could maybe Staples have done to prevent that from happening in the first place? Any ideas?
You could have like an ethics committee.
Yeah.
Like this, it's just have somebody else look at it at least.
Yeah, right. Yeah, I think that's a huge part of it, right? It's just think about it, have some point along the process where you think, oh, what could possibly go wrong? Are there any ethical considerations here? And I think for a long time, I think it's taken us a while to kind of realize that that's necessary, but we're starting to realize now that that's necessary. And that's also why we're encouraging you guys as you're doing your projects to think about that aspect too, think about what the potential ethical implications are. Any other thoughts on that?
It seems like by not actually taking into like the ethical considerations, it's actually detrimental to their original purpose, because their algorithm and what they're actually trying to do, it's not as effective, because without those ethical considerations, like there's like I guess like holes or irregularities in their data, and it's not as accurate as they would want it, even though.
Yeah, I think that's a great point. I mean, so there is even a certain extent to where, I mean, we think about, well, we should do the ethical thing because it's the right thing to do, but also in a lot of circumstances, it's also the best business, definitely to be being fair and not alienating certain customers. And also in this case, it's probably the people in the poorer neighborhoods would be more motivated by that discount than in the wealthier neighborhoods. So it may have had kind of not the effect that they intended. Any other thoughts? Okay, well, it's 1:45, so why don't we call it a day? And I'll just say that there were a lot of things that we didn't get time to talk about, like privacy and societal consequences. So I do encourage you, if you're interested, to register for that course, check out the remainder of the materials. I'll post the link for that in Slack. But yeah, okay. Take care, everyone, and have a good weekend, and I'll see you next week.
See ya.
Bye.
Thank you.